Board. All right. I'm Conor Patrick. I'm a graduate student at Virginia Tech, and this is Getting Secure on Two-Factor Authentication, Hands-on Learning with U2F Token. So I'm doing a thesis program at Virginia Tech. I do research on secure embedded systems. So basically that means researching how to implement cryptographic systems or secure implementations on embedded systems, systems that don't have very good resources like RFID tags, smart cards, things like that, as well as side channel implementations, being able to break an implementation just by looking at its timing characteristics or its power traces. Or other attacks where you have physical access to a device. Now, I'm not really going to be talking about any of that per se, but I'm going to be graduating this in June, hopefully, fingers crossed, and then I'll be starting work at Johns Hopkins Applied Physics Lab in the CyberCore Scholarship for Service program. If any of you are familiar with that, it's basically like ROTC, but for cybersecurity and civilian government. As for why I'm here, I had a side project not too long ago where I made my own U2F token. It's open source. It's a two-factor authentication token. As to why you would use U2F versus other means, I'll explain that. As well as another thing I did is I made a lot of them to sell them on Amazon as kind of to finish off the project, and so I'll talk about that experience as well. First, I'll go over some security fundamentals. I'm not too sure what each of your backgrounds are like, so just to be sure, I'll go over some fundamentals, the history of two-factor authentication protocols, how each one builds on the next, and how we kind of got to U2F, and why I think U2F is kind of the best for two-factor authentication in some sense, but maybe not for everything. I'll talk about my experience making my own U2F token and manufacturing those on Amazon, or manufacturing those and selling them on Amazon. And then finally, how U2F 0 works. And U2F 0 is the token that each of you should have in the red lunchbox free stuff bag that you got. Okay, so two-factor auth stands for Universal Two-Factor Authentication. It was made by the standard was developed by FIDO Alliance and Google, and they've been pushing it and trying to get adoption for it by various websites for a while. YubiKeys support it. How many of you have a YubiKey? Just curious. No one. Okay.
We're behind in education.
Great. I'm glad that no one raised their hand. Basically, as far as two-factor authentication tokens go, YubiKey I'd say is one of the leaders in terms of what's hip and modern. They have, we'll talk about it more later. So you can't just use U2F for everything. The service that you're trying to authenticate against needs to support it. Obviously, right now, a handful of browsers like Firefox and Google support it, and web services like Gmail, Duo, GitHub, Dropbox, Facebook, they support U2F, but it's not quite ubiquitous yet. Have any of you heard of these three things? The number of ways that you can authenticate. It's either something you know, password, something you have, the token, or something you are, biometric. I think the best biometric authentication scheme I've seen is on the new Apple devices with Touch ID. It works pretty well. And so two-factor authentication typically falls in the last two things. You don't just add something you know and then have a second password, something you know that doesn't really count. You need to have a password and then one of the next two things. Or you could have just the last two things, but you don't see that very much. So why you would want to add two-factor authentication, normally it's to prevent phishing and compromise accounts on a large scale. So if you're running an organization, you have a problem with user accounts getting compromised, you can try to annoy them more about having better passwords and not using them across services or whatnot, but you can't really rely on users to ever do that, and so you force them to have another authentication option that they have to go through. And have any of you for your organization set up two-factor authentication yet? Not one person? Nice. Testing. Okay. Yeah, and it seems like something that people are kind of dreading to get to, and maybe not everyone needs two-factor auth. As far as targeted attacks, so this is when you have someone that I want to compromise this person's specific account for whatever reason. Two-factor auth might make that a little bit harder, but when you want to physically compromise someone's account and like do recon on that one person, you can probably find other attack vectors to compromise their account. And so two-factor auth may not be helpful for the targeted case. But on a large scale, for like phishing and stuff, it's great.
Just on that previous slide, I might be slightly off topic, but if you have time, as our school district, we try to figure out how to manage compromised accounts and stuff. One of the things we talk about is encouraging password managers or password lockers and blending those with multi-factor. I'm just curious what for security practices, if you could touch on that at all.
Yeah, absolutely. I think password managers are great. As long as you have like one great password, you use two-factor authentication for your password manager. That's actually what I do, and then the password manager should handle having a high entropy password for your service. I think that's very great. I don't talk very much about that later on. And also, if any of you have any like comment or question, feel free to interrupt me. It's best if this is interactive, and I don't mind being interrupted at all. So some fundamentals. How many of you intuitively know the difference between symmetric and asymmetric encryption? One, two, a couple? Okay, but not many? Okay, so I'll go over those things just at a high level, not like at like my graduate student level or anything. It's important to, especially when you're implementing authentication schemes, it's kind of like important to know how they work under the hood and whether or not you're using like a legacy system or not, just at a high level. It's pretty good. For AS, DS are kind of like, over the years, common symmetric algorithms, programs. And RSA, probably you've heard that when you work with like certificates and stuff, RSA tokens and ECC. Okay, so symmetric crypto is kind of like the most like basic encryption scheme. You and the person that you're talking with are going to have some sort of shared secret or shared key. And if you want to send a message secretly, you encrypt that with the same key, and your recipient will also have that key, which you can use to decrypt it. And anyone eavesdropping would just see ciphertext and wouldn't be able to see the message. Symmetric keys is where you have two keys you use for encrypting or decrypting. So one key will be used specifically for encrypting, and it can't decrypt the message. You use the other key for decrypting the message. And what this allows you to do is that you can designate one key as being public. Anyone can have it. And then you keep the other key private, just like you would in a symmetric system. You don't let anyone see it. And so you can kind of imagine each person having their own public and private key pair. And if Alice wants to send a message to Bob, she would take Bob's public key, which she can because it's public, and encrypt her message with Bob's public key. And she can't decrypt it anymore because to decrypt it, you would need Bob's private key, right? That's the decryption key, and only Bob has that. And so since Bob's dealing with the decryption key, he can decrypt the message with confidentiality. So asymmetric crypto seems kind of nice in that everyone has their own private public key carrier. You don't need to worry about distributing a shared secret between each other. So it seems like why not just use asymmetric crypto all the time? Why do we even bother having symmetric crypto? Does anyone have any ideas?
Symmetric's faster.
Yes, that's a great point. So asymmetric systems like RSA and ECC tend to be computationally intense. So normally when you have to use these systems, you just use them to encrypt something small. Basically, use them to encrypt the shared secret that you would then use for a symmetric algorithm. And then you can continue your secure session. So if you were like try to encrypt something with a RSA or ECC, and that you want to encrypt like, I don't know, a megabyte of information, that could take on the scale of like minutes to hours, depending on what type of computer you're using. Whereas symmetric, it would be kind of relatively instantaneous. Okay, so security fundamentals, confidentiality, integrity, authentication, assurance, availability, or CIAAA. If any of you heard of these, it's kind of like thrown out in different places. So kind of what I've gone over kind of covers confidentiality. So if you encrypt something and you have an eavesdropper, they can't deduce what the message was. However, to be able to implement an authentication scheme like in two-factor auth, you can't just have a system that only offers confidentiality. You need to have integrity and authentication. So I'll go over those as well. So suppose in a public key crypto system, Bob is expecting a secret message from Alice. And in this system, Alice is just going to encrypt a message with Bob's public key No one can except for Bob can read it because Bob's the only one with the private key. And so there's confidentiality. Any eavesdropper can't learn what the secret message was. However, there's a problem with this system. Does anyone want to point it out?
Well, if Susie has the public key, she could say she was Alice, couldn't she?
Yes, exactly. So there's no way to authenticate that this arbitrary message actually came from Alice. So maybe not Susie, but Mallory in this case. She has Bob's public key and could send another fabricated message, and Bob has no way of telling what it is. And so how you fix this? First, we'll cover integrity. Have any of you heard of hashes? Okay, so typically when you download like an ISO file or a large file, it could be low-hanging fruit if an adversary wanted to like modify, put a backdoor in like an operating system or something. The place you download it from, maybe Microsoft, provides hashes with that file and says, okay, if you recalculate the hash on this operating system, and it's the same as what our hash is, then you know that it hasn't been tampered with. Right? So these hashes, you want them to be one way. You can't reverse what the hash was on, and they're nearly one-to-one. So basically, for any sort of input, there's a very good chance that the output of your hash function won't collide with a different input. Otherwise, you could have a good operating system and a operating system with a backdoor in it, and they both have the same hash, and you won't be able to verify. Some example hash algorithms, MD5 and all the SHAs. MD5 is kind of broken in that people can find collisions in hash function in the MD5. SHA-1 recently, there's been a project with two PDF functions or PDF files that are completely different, but they have the same SHA-1 hash. So you shouldn't use SHA-1 anymore. It's kind of a proof of concept that happened recently. Bcrypt is interesting because it's a hash function that's been designed to be computationally hard, and so if a person gets access to like a password hash list and they want to like brute force and try to figure out what the passwords were, it's going to take them longer than it normally would because Bcrypt, that specific hash, has a large memory and computation bound, so it'll take a while to compute. But a little too far in the, you don't need to understand all of that, but so if we want to add authentication, Alice, in addition to sending her ciphertext to Bob, should also include some sort of authentication tag or a signature. Basically, you take the hash of your ciphertext, and what this does is it shortens the ciphertext to a fixed 160 bits or 256 bits every time, because the output of the hash is fixed to that size. It's not reversible. You can't figure out that it came from the ciphertext, and it's nearly one-to-one. And so what Bob can do is he checks the signature so Alice would encrypt this hash with her private key. So everyone has Alice's public key, so they can decrypt this hash. So that's what Bob should do. He decrypts the hash. And then he can recalculate the hash on the ciphertext that he got from Alice. And if those match, then he knows that this came from Alice, because Alice is the only one that has the public key, so no one could successfully encrypt the hash to decrypt to something meaningful. No one can change the ciphertext, or else the hash that Bob recalculates wouldn't match. Does that make sense? Maybe some of you are already familiar with this? Yes? Questions? Okay, good. So moving to challenge response is a pretty simple authentication scheme when you want to authenticate people. So with symmetric key-based systems or hash-based systems, if you want to authenticate someone, you send them a challenge, which is normally a random string, a random number, and you and this person would have a shared secret. And the person you're trying to authenticate, Alice, would return this challenge encrypted with your shared secret. And then you would decrypt that challenge with the shared secret, and it should still be that random string that you sent them. And you would know that if they're the only ones that have that shared secret, then they must be who they actually say they are. You could also do this. You could do this with symmetric encryption, or you could do this with a hash function, where you just concatenate the challenge in the shared secret as the input to the hash function. Yes.
How do you make sure this shared secret is secret? Somewhere along the way, you have to send the person.
Yeah, that's typically the large fallbacks of these kind of systems is that by this point, you already assume that you've securely distributed this shared secret, and so it depends on the application, but that's kind of a problem. Whereas in public key based, you don't have to send any sensitive information over the wire. Each person will have their own public-private key pair again. So if you want to authenticate someone, you have their public key already, so you send them a challenge. They encrypt it with their private key, and if you're able to decrypt it back to the same thing, then you can authenticate that they are truly the ones with that private key. And this is something that this private key is something they can generate on their own. However, if you still need to be able to get their public key and be sure that it came from them. How you do that in the real world is that you have this chain of trust that goes back to certificate authority. So you have this list of people that are like everyone agrees on that these people are actually who they say they are, and then you have a list of them in your browser. And people give you a public key, they'll have a signature that has the certificate authority's signature on it. So you've already hinted at it, but is it better to use public key or shared secret-based challenge response? What's the trade-off here?
I would think it depends on what you're using it for.
Yeah.
If you have control over both sides of the shared secret.
Yeah, so I guess if you can easily distribute the shared secret, then symmetric challenge response is kind of nice. However, for asymmetric can be more flexible in that each person or each party can generate their own private public key pair. But if you're using a hardware token or an embedded system that's doing the authentication for you, again, asymmetric crypto is computationally intense. It's not like a PC or a laptop that can just do it like that. A small microcontroller won't be able to handle asymmetric signature schemes in a timely manner. Not always. Not in software. So I've kind of been talking about like how you implement these schemes, but I don't want you to, if you don't really especially have experience in this, you shouldn't try to implement this on your own. Or don't roll your own crypto is kind of like what people say in the field. Because I'll just throw out this commonly used quote by Charles Babbage of 1864. One of the most singular characteristics of the art of deciphering is the strong conviction possessed by every person, even moderately acquainted with it, that he's able to construct a cipher which no one else can decipher. And so people just getting into security always get the naive sense, it seems, that they can just create something so random and secretive seeming, and that no one knows about it, that no one will be able to decipher it. But for a very long time now, if you're not using something that's been used or proven that it's actually secure and robust, then it's probably not a good idea. So if you're not like don't already have a lot of experience in this area, or you're a PhD student, then just don't use something else that already exists. Yeah. In the crypto field, this quote is thrown around a lot. All right, so now on to two-factor authentication. I guess the most basic two-factor auth scheme starts with hash-based one-time passwords, or HMAC-based one-time passwords. HMACs are just hashes with a shared secret, kind of what we talked about earlier. So basically, if I'm a client and I want to authenticate against this server, we both would have a shared secret somehow, already magically. And we each would have a counter that's synchronized to 0 or some fixed value. And to generate a one-time password is just, I mean, what it says, it is a password that you use once, and the next time you generate a password, it'll be different. So once I generate one-time password, I'll use that, and the server will check it. They calculate it by calculating the hash over our shared secret and the counter. And then once we do that once, we increment the counter, both. So next time I calculate a hash, then one-time password will be different. Yes?
So like Google's two-factor authentication, like on the app that you can just run and type in the number of sequence?
Yes, it's close. I'll talk about that next.
Okay.
Yeah. So the problem with this, it's kind of hard to keep in sync. So if you like try to generate a one-time password and like the internet drops out or whatever reason, that means you incremented your counter, but the server never heard anything, and so its counter is one behind you. And so your one-time passwords are going to not be the same, and so you're going to need to have some way to like figure out how to synchronize that, but it's kind of messy. Also, the user typically has to enter in the code themselves, and so it's not quite autonomous. Generally in crypto, when you have the user in the loop like this, it's not a good idea. So time-based, one-time passwords. Imagine normally you see a lot of apps use this, like Google. Instead of using a counter, you use time, and so as long as you and the server you're authenticating against has the right time, then you're in sync. You don't need to worry about that, so that's kind of nice. And so computers, they keep time by the number of seconds since 1970, and so you add the number of seconds since 1970 plus your shared secret, calculate the hash on that, except maybe you divide it by 30 seconds to give maybe like a 30-second window, like that. Again, the user has to enter in the code manually still, or I guess if any of you have so the shared secret is distributed potentially and securely as well. It's just distributed over the same channel that you use to talk with the server you're trying to authenticate against. Normally it's like a QR code that you scan with your phone. That's basically the app taking the secret that the server generated and copying it, and then you can generate one-time passwords off of that. But if an eavesdropper sees that, then they can duplicate your factor, your authentication scheme, just like that. So now we get to Yubico. So basically what they solve is that with these tokens, you don't need to enter in a code anymore. It's autonomous. So that's kind of nice. So how Yubico, since some of you have one, how it works is that you plug it in over USB, and you select an input field on the web browser. It's the one-time password field, just a regular input. And you press a button, and it spits out a bunch of keyboard codes or ASCII codes, characters. And that's an encoding for the one-time password that Yubico can authenticate. And so those codes are really just the encrypted version of the shared secret, some counters, and the time. And since when you buy one of these tokens, the shared secret has already been distributed at manufacture time onto the token in YubiKey's database. Google, if you're trying to authenticate with Google, Google has no idea what the shared secret is, so they can't really. This one-time password you're sending them means nothing to them. They can't do anything with it. So they have to send that, they forward that to one of the Yubico servers, and then Yubico can figure out if they can authenticate you or not. And then they tell Google whether or not if it looks good. So this is autonomous, but it requires a third party to be integrated into your authentication scheme, which I think is really annoying. Especially if it can't just be any third party, it has to be Yubico. Not to say that they don't do a bad job at this. They have pretty good servers and they do a really good job at it, but if you're setting up like a host system to authenticate users and you have to add YubiKey, that's just kind of like an extra dependency, an extra hassle. And for me, if I want to make my own two-factor authentication token, for my scheme to work, I need to have these servers to be up to integrate with services. That's a whole nother pain.
Excuse me, can you go? I'm missing something. So you get a USB
Yes.
token? Is that what you're saying?
Yes. Yeah.
Okay.
Yeah. This is just commercial product. Different versions varying between $15 and $50.
Can those be copied so if somebody gets it because it's in the store file left and then we can copy that to compromise it?
Sorry?
Do those have protections so we can copy? So let's say that somebody leaves it in their desk drawer and somebody goes, oh hey, copy the contents. Is there protection from that, or is there another downside?
So could someone take the token, read out all the information, and duplicate it?
Yeah, copy all of it off of that device onto another thumb drive.
Yeah, great question. It's definitely a good attack vector that people would be interested in doing. But it's not just a regular thumb drive. It actually has a smart card in it, and so I don't know their implementation details, but hopefully any private keys stored on there are write only. you can't read back.
It's probably encrypted too.
Yes. Yeah. Yeah. So there's a lot that goes into that. However, I know you can update that shared secret if you download an application from Yubico, and so the user is allowed to update that after manufacture time, and so that could be a potential issue, but most people don't do that. Okay, so now we get to U2F. It's just asymmetric crypto-based challenge response. and it's just as simple as how we talked about it previously. FIDO and Google, they provide specification standards for U2F to work over USB, NFC, and Bluetooth, and they'll probably add more as we need it. And this is great because then you can use it with computers, mobile devices, other devices have any Bluetooth, any of those things. Now, to be able to authenticate, you still need, the server needs to get a public key from you that they can use to decrypt your challenge, right? So there's 2 steps. Before you can authenticate, you need to register, and so normally you go into the web service and you click add a security token, and they'll say, okay, plug it in and press the button. So when you plug it in, what the service will do, it'll send your token a register request, which is basically says, give me a public key that I can use to authenticate you later. Optionally, it also has a challenge that it sends you in that you sign using a special attestation key pair, and you give them your attestation key, which is a special certificate that if the service wanted to, it could authenticate that the token that you're using is what it wants. So basically, if I only wanted my users to use Yubico keys, I could use this attestation certificate, which has been signed by Yubico, and I could use that to authenticate that they're using the right hardware token. They can't just use anyone. This is optional, and in practice, that you can use any U2F token you want, but maybe from an organization point of view, if you wanted to have a specific token that only your users wanted to use, you could extend this to be able to authenticate that. But TLDR, this just means give me your public key. Your token will generate a new private key pair specific to the service, and you give them the public key and you keep the private key. Okay. And then later, when you authenticate with the same service, the service will give the token an ID specific to the public key that you gave them, so your token knows which private key to use to encrypt the challenge or to sign the challenge, and then give them the signature, and the server will authenticate that signature using the public key that you gave them during the register step. And this is just regular challenge response using asymmetric crypto. Okay. Any questions on any of that before I switch topics? Yeah.
What's the security as far as losing the token itself, and the fact that it could be potentially tied to somebody? Obviously, they have to have your other account information even to start the process of using it. But if they did have that, is there anything as far as potentially shutting them down from your account or disassociating that from your account? Is there any security behind that piece of it, or is it you lose it?
Yeah, good question. So at first, it's definitely just like a car key. If someone steals your key and you don't realize it in time, they can pose as you. But if you have another way to authenticate for your service, which I hope you do, maybe like backup codes or something, then you can definitely remove it.
Okay.
But it will depend on the service that you're using.
Okay.
So now I'll talk about my experience designing and building and selling on Amazon a U2F token. This is the token that you all have in your bag, or the U2F 0 that I called it. So when I started this project, I had a few design goals. I wanted to obviously be secure. And what that means, it kind of goes on your topic with your question with the being able to read private keys. That's not something you want to be able to do. And when people write software, generally it's hard to tell if it's actually secure or not. There's no absolute secure test. What you do is you add a lot of isolation and multiple security levels so that if there was a bug, then hopefully something else would prevent it from being exploited. And so I wouldn't want a token to be plugged into a computer and then have malicious software on it be able to solicit some sort of buggy request and then read out a key. I wouldn't want that to be possible. I also want it to be cheap because I'm just a college student. I don't really have any money. And crypto performance is, so for U2F, it needs to be able to compute signatures using ECC or asymmetric crypto, which you won't really be able to do feasibly on any microcontroller because it's computationally hard. It's just a graph that I took from NIST Lightweight Crypto workshop in 2015, but have all of you heard of ARM? It's basically the chip that goes on mobile devices, and so this is just some tests on ARM chips, which are on the relatively high end of the embedded chip space. This is how long various ARM chips take to compute a signature on ECC, and it ranges between 200 milliseconds to 2 seconds, and so since that's on the higher end, on the lower end, 8-bit microarchitectures, MCUs, to compute a signature will probably be on the scale of like 5 to 10 seconds, and so that's not really acceptable to have a user plug something in, press a button, and think it's not working because it didn't work in under a second.
You see, that's just because you young folks don't remember, 56K dial-up modem. 10 seconds would have been, oh, really? I didn't even have time to get a cup of coffee.
56.
I guess maybe nowadays we've spoiled it, so you have to use special chip.
I'm with you, Connor. I guess I'm a young guy.
Us young people, thanks. So as a designer, what you look for in security chips, you can't just use anything. It won't work if you just write it in software. So they'll have like in the data sheet, they'll have various peripherals they'll have on this microcontroller unit, in addition to the actual the CPU architecture. And hopefully in the corner they'll have like something attached to a bus that says like crypto or RSA or ECC. And what this means is that they've implemented the algorithm in hardware, and so that you don't need to write it in software. You just say, okay, here's my key, here's my input, run it really fast, and give me the result. And that's basically what you have to do. Now, normally when you look for specific peripherals on microcontrollers, you can find tons of options. You can buy 1 to thousands off the shelf from other vendors. However, in the security realm for semiconductor companies, that is not true, because unlike software, if there's a security bug, the vendor can just issue a patch and you update it. It's no problem. People will still use the software. If you find a bug in a chip that's being sold for a security feature and is no longer secure, you can't fix that because it's laid out in silicon. You have to make out another chip, which you have to fund with money that you're not getting from your consumers because they're no longer buying your chip. So for me to be able to, how they solve this is that to sell these secure chips to people, they make them sign non-disclosure agreements. So if they do find anything, they can't tell anyone. They need to have minimum order quantities in the millions per year, so that way they've already invested a lot in this chip themselves. And so for a person like me to be able to access one of these chips, I don't have a chance. However, there are a couple semiconductor companies that do offer like a very small selection of chips that accelerate symmetric crypto, which is great. I found one chip. It's not even a microcontroller unit. It does ECC crypto, and that's it. And so I had to combine this with another microcontroller. So 256-bit ECC, which is what U2F uses. It has a hardware random number generator, which is important because if you're generating keys for service, you don't want all the keys to be the same. That would be very easy to duplicate it. You wouldn't need to read it at all. So having a good source of entropy or random numbers is definitely required. And the keys, the private keys, are write-only. So this solves my design goal to be secure, because even if there's a bug in the software that I write, it's okay because the private keys cannot be read from in hardware already. And they're 70 cents each, which is cheap enough for me. So overall design, you have front end to handle like USB, to be able to communicate with the outside world, the crypto to be able to compute signatures in a reasonable amount of time, and then a button and an LED so the user can say, yes, I want to authenticate, and see that it worked. This is what it looks like. You can see it from your bag: USB front end, crypto chip, LED, button. As far as manufacturing, the printed circuit board, making printed circuit boards and assembling the components onto them and doing the soldering is pretty easy. There's tons of fabs that do this in China, India, and the US. Just pick one. I picked the cheapest one that seemed reliable. The crypto chip is a little bit different because it can't be programmed like a regular MCU. You need to be able to have special drivers to communicate with it and configure it for your specific application, and then lock it permanently. And so that's because of that higher level of complexity. I'm not really going to trust setting this up with my manufacturer to handle this. I'll probably make a mistake and it'll be expensive. And so I just went through and programmed all of them myself after the printed circuit boards were made. I sent an order for 1,100 units, cost about $4,000. Well, $350 for the printed circuit boards themselves, and then $3,000 for all the components and putting them on the printed circuit boards and assembly. And then from China, paid about $200 for shipping that and in tariffs. Although probably could have gotten around the tariffs if I worked a little bit closely with the fab to declare the packages something else. When you ship things from China, there's kind of black magic in shipping. So, yes, I don't know too much about it yet.
There's a crypto attached to it.
And then, oh yeah, don't say crypto. It's kind of like a project that I was kind of new to in school. I worked on it on and off for about 6 months, and so just from like ordering new prototypes and buying new tools, maybe another $500 of costs that you can't really predict in the beginning. And so I was hoping like the BOM cost of each, the cost of materials for each token would be about $3 per, but maybe just end up being closer to $4 per token. So automating, I have to do all the programming myself, so I just kind of like set up this little like sketchy like pipeline for like plugging in tokens to a USB port and then plugging in the programmer, and I could do up to like 3 at a time. Initially when I was developing, it would probably take about a whole minute to program a token start to finish, and I didn't want to spend 1,100 minutes, so I was able to get it down to maybe about 10 seconds per token. So that took me about like 4 or 5 hours. Just like watch a movie while I chug through everything. This is a time lapse, just me like plugging things in, unplugging it slowly, and then getting through it. And then you can see the
progress in there.
Yes, yeah. I think going back, I would probably like make like a better test rig to speed this up more. But first time that I've done it. All right, now that all those made, you gotta put them on Amazon. So Amazon FBA, which stands for Fulfillment by Amazon, I think. But basically, it's just a program where Amazon have inventory that they produce and sell. People like can just ship inventory to Amazon and they'll sell it for you. Take like some cut of that, but then you get to use Amazon's distribution, which is pretty good. I don't want to like sit in my room and then maintain my own website and try to like market it and then like ship tokens every day. I'll just give that to Amazon. And then Small and Light has another like selection of categories that different products would fit into, and they have their own like setting how fees are done. So for this thing, it fits into the Small and Light program, which is like the cheapest fee program, which is great. So if you want to sell a product on Amazon, there's a number of things you have to do, and it depends on whether or not you own the brand and if a listing for that product already exists on Amazon. So U2F0 is new. There is no existing listing on it. Otherwise, that's the easiest route. If the listing's already there, you just copy the listing and then you ship it to Amazon. It's already been vetted, and then you're done. But if it's new, then and you're the brand owner, Amazon has these list of requirements that you need to go through, like having a website and specific packaging, blah, 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 and then you submit your application. Amazon looks at it and like, okay, yeah, we'll sell your product. But Amazon just wouldn't recognize this at all for like stupid reasons, and it was like all automated. You could never like talk to a person. They'd be like, we don't like your website. We don't like your label. It should be printed out directly on the cardboard, and there isn't cardboard, and so it's a huge pain. However, Amazon has this other option for when you're not the brand owner, so you don't really have control over the packaging or the website necessarily. So what Amazon asks you to do in that case is to write a letter to the brand owner asking for permission to sell on Amazon. And if you have that letter, then Amazon probably approve it. So I just wrote myself a letter asking for permission to sell on Amazon, promptly approved myself, and sent that in, and this got approved like immediately. Good. I don't know.
Did you read that somewhere, how to do that? Did you come up with being able to do that? That's very interesting.
Well, I mean, just reading online, you see the different options, and like, obviously I knew this is probably like kind of like a sketchy way, but I was like frustrated and figured I'd just try it.
You are a college student, so.
Yeah, it works. There's no, and it's all automated. I don't think a single person would see this except for you guys. So sales, I wasn't really sure if this would like sell very well, but when I initially like wrote a blog post about it, there was like a huge spike, and then after that, maybe sold between like 1 to 20 units per day until it sold out, and so it did pretty well. I'll probably try to keep it stocked. And then the feedback, I thought it would do pretty bad because it's just like this dinky thing on a printed circuit board, no case. You're selling it to people on Amazon that don't necessarily know what two-factor authentication is or U2F, but surprisingly it did pretty good, and so I'm surprised. Okay, so now how does a token actually work? Probably figure it out without me telling you, but it supports the two commands, register and authenticate, like we went over previously. You just stick the token in, and the LED will turn orange when it gets a request, either for register or authenticate, and it won't respond to that request until you press the button. That way you don't have a token that's granting unsolicited requests. Press the button, it'll turn light blue, which means it worked. You're done. If it turns red, which it shouldn't, that means there was an error. Plug it in. If it's an idle, it's not doing anything. It'll just kind of like pulsate green or blue. Okay, so for an organization, how this could be helpful for you guys. It's, like I said before, it's kind of like a digital car key. If someone steals it, then they can pose as the user for that particular factor. However, if you do learn that it was stolen or compromised or lost or whatever, you can remove it, or there should be some other like channel for you to authenticate, like call someone or use a backup code or something. As far as adding U2F to your host machines or your servers or whatever your users need to authenticate to, it should be kind of straightforward if you have the development experience for your authentication server or whatever that is. UbiCo provides working software libraries for most platforms, C, Java, Python, PHP, and there's even like WordPress plugins. You probably just click through and add it to your WordPress site, and then users can authenticate using U2F and potentially even replace passwords. No third-party integration needed. You don't need to talk to Yubico. You just take their code, and it's all open source. It's a potential password replacement on GitHub, which is a popular website that I use. They have this option where you can enter in your password and authenticate, or alternatively, you can stick in your security key and press the button. I really like that. So maybe if I'm at home and I can just leave a security token in my computer, I don't think anyone's going to mess with it. I can just press the button, and basically then GitHub can authenticate that I'm at my home computer because it has my token plugged into it. Works with USB, Bluetooth, NFC again. So if you want to authenticate on like a mobile device, you should be able to work that out. Although that might be a little bit more complicated because it's mobile's a little bit different. Yeah, I know with YubiKey tokens, you can use NFC to authenticate on Android devices, and they have an app for that using U2F. But Apple doesn't like developers making their own NFC applications, so you can't really do that. But you can use Bluetooth, but I'm not really sure of anyone that's done that yet, but you could. And if you want to authenticate or restrict users to a specific hardware token of your choice, maybe you make your own or you only want to use YubiKeys, you can also do that as well. Potential pitfalls is that you need a plan for lost tokens or tokens that get stolen. Similar like how you would do password resets, I guess, or you have other authentication schemes. Not all devices or mediums will support U2F because it's still kind of a new service. I know like I can think of maybe like 5 or 7 services that use it, but maybe not many more than that. And you may not have a developer that add like these software libraries to your current infrastructure right now. That may not be an option. You can build your own. You can either order them in bulk off Amazon. There's a number of people, not just me, that sell tokens in bulk that you can buy, and that's probably like the easiest thing to do. Alternatively, you can fork my project. You can copy my project. It's all open source, and you can build your own, or you can add a custom logo or make changes or whatever you want. I know there's a couple people that are doing that right now. And here's the link for the source of the project. That's it. If any of you have any questions?
So Conor, can you go back right there where you say you purchased the tokens in bulk?
Yes.
Would you end up programming them as you were doing after you I'm lost.
Sorry. No, I mean, when you purchase them in bulk off Amazon, they're already finished, and so you don't need to program or anything. That's the easiest route. You just give them to your users. Since you purchase them in bulk, there's probably some sort of discount that you get there. Alternatively, you can talk to someone that's made their own U2F token like me to order them in bulk, and I would set that up as well. At least that's what I did for the conference. And you shouldn't need to program it.
Pardon?
And you shouldn't need to program the one that you got for this conference. I did that.
So if we were going to look at purchasing in bulk, would you quickly go back over the criteria again that we would be looking for, possibly? Or, I mean, we talked about some of the different encryption protocols and usability and whether or not it's going to contact a third party. I just wasn't sure if there's sort of a standard set of features that we should be looking for.
So when you look for U2F token specifically, it's not going to vary too much. But when you look at two-factor authentication tokens, you're going to see the time-based generating tokens, which are probably like the oldest ones, like the old RSA keys that you see sometimes. And then you'll see Yubico tokens, which are kind of relatively new, a little bit more expensive, and they have their own protocol. So with those, you would need to add Yubico integration to work with your services. Or if you want to use them for services that already have Yubico or U2F implemented already, you don't really need to do anything. But if you're trying to like add your own to your own service, U2F is probably going to be the easiest.
Standard,
yeah.
so as long as it conforms to that standard,
yes.
It probably doesn't really matter who we would order it from.
Yeah, just pick the cheapest one or something.
Okay.
Yeah.
And you said that you can use the libraries from Yubico for your own stuff, so you technically don't have to touch base with Yubico as far as.
Correct.
Okay.
Yep.
So still not quite third party in that fact, but then that means you're just setting up on your own end. So.
Yeah. So open source, no strings attached.
Okay.
Open protocol, so you could write your own library if you wanted.
So how sturdy are they without a case? I mean, getting like carpet shock on it or something like that would fry it? Or,
So static shock, I haven't heard of anyone breaking it that way. I think this old key ring kind of like would wear off and it would break. I know that breaking off. Sometimes the electrostatic discharge protection and some of the capacitors will like chip off, but you don't really need those, so it'll still work. Yeah, just for show. The LED on mine, so I've been using mine since I've like made it on day one, and it still works. But the LED doesn't work anymore. It's just dead, but it like still works under the hood. But it depends on like how rough you are with. Maybe just keep it on your desk, in which case it'll probably last for a very long time. If you keep it in your pocket on your keychain, maybe it'll last probably a year, depending on how rough you are in your pocket. It's a good question.
What do you think the sort of the path forward is, the trajectory, adoption rate? Do you see this being ubiquitous? Everyone using this method of authentication?
For U2F? So I think when U2F started, it was definitely like slow. It was just like Google and maybe like two other services that use popular services that would implement, and no one really knew about it. But from what I see, like people talking about in the field and like what they're like recommending to users, there's a lot of like craze or rave for U2F, I guess. And so I think it's going to be picking up. Even like Facebook just supported it maybe like a month or two ago, which I think is a really good sign. Once they do it and Google's got it, I mean, a lot of other companies are going to follow. So it's still probably in its early stages, but I think it'll become ubiquitous. Huh?
Is Amazon?
I don't think so, no.
PayPal
Yeah.
or your bank or...
Banks will always be behind, and unfortunately, because I think PayPal, I think they might support it. Normally, they're pretty good. I don't even know if
Citibank supports it.
Really?
Yeah.
Oh, I'm surprised. I wouldn't have expected any bank to have.
That on there too, so you can use your token.
Yeah. My bank doesn't even have two-factor auth to begin with.
It looks like if you go to dongleauth.info, they give you a list of all the different websites that support OTP and UTF.
Yeah.
So we can kind of look up which ones.
Yeah, you'll see. OTP has been around for a lot longer, and so most websites will support that. And then U2F is a little bit newer, and so you won't see that supported as much.
What was the name of that website?
Dongleauth.info. You can just type in what you want, and it has it based on like basic.
I don't have any.
Sync, cloud computing, finance, entertainment. Connor, on your GitHub, it looks like you have a case, like 3D printed case. How does it work? Like,
It's
I
not-
not so much as specifically, but I should say, is it good?
I think I like made that in a night like a year ago and like tested it out and it kind of worked and I threw it up there. So I would say if you really want, try it out. And if it doesn't work, hopefully you'll mess around with it and commit. It's not an official case, but use it at your will. There's a 3D printer downstairs by the bar, which I found interesting. So
We just never know when people are going to be invented.
Yeah. So.
I had a quick question. I've seen some descriptions of, like when you mentioned the different factors that we have, something you know, something you have, and something you are. But I've seen reference to, instead of two-factor, like two-step or multi-step verification, which is not necessarily using all of those factors, but
it's like answer these security questions and then
or it's
enter
like,
in the code from your email.
Right. Yeah. That is. And so, are you seeing like that? That seemed to be like on the upswing for a while, right? But the complaint was, well, it's not really two-factor, right? It's two things or or it's something that your phone knows, but it had to be transmitted to you to begin with. So is it that verification code, does that really count as something you have or own, right? And you'd mentioned earlier, that transmission. Like I don't know, what are your thoughts on that? Are you seeing a change, like moving away from two-step and toward two-factor?
Yeah. So I guess what we describe as two-step, I definitely think, or I definitely hope that people are moving away from it. I know when I have to fill out security questions for websites, I get really annoyed. Yeah, I'm like, okay, I can answer these questions, and if someone like called up one of the customer service reps, they could probably social engineer all those questions and get through it. Where it's not real security. These kind of solutions are like, I think goes back to like the homebrew thing, is that you have some IT group at this company that is tasked with making their setup more secure, and so they come up with these things, and like how successful they are kind of vary. Whereas sticking to a standard like two-factor auth is obviously proven, tested, and well vetted. I know a lot of people when they get stuck with these security questions, they'll use their password manager to just generate high entropy things and letters, and then like save that in the password manager. So if they do like get locked out, they'll call up the customer service rep and be like, oh, it was my father's side AH uppercase at TEL and things like that. So.
As you look at the future of security, where do you see it going? Do you see this as one of the routes it's going, or do you see others?
I definitely think for like the web, U2F will definitely, I think will get a lot more ubiquitous. It's a pretty nice protocol. For mobile devices, that may not be the case. I think Apple's going to take the lead on that with Touch ID because that's authenticating like a biometric. And for those of you that haven't used it, it's actually pretty nice. I really like it. I think mobile devices will probably pick up on biometric authentication, and then
my finger must have a problem on Apple because it recognizes it one day and not the next. So I'm not quite sure if my finger's changing.
It's only going to get better though. But maybe not for everyone.
Like little Windows.
So does Windows have?
Facial recognition, 3D with their 3D camera.
I probably wouldn't use that. I don't know, there's some privacy problems there. They're taking a picture of you, and then there's like a database of people's authentication faces. And plus, it's really like a computer vision problem, which is not a solved problem. You can just take a picture of someone in the same thing and hold it up to the camera just right and try to bypass it. So I think right now that's a little bit lofty. Yeah. A little bit of a gimmick for users to be like, oh, cool, that gave me in my face, but.
How would you see this implemented, like in a school district? Like if someone was to say, hey, run with this, we want to make sure all the students authenticate well and staff. How would you implement this?
So what my school did, they're not using U2F. They're realizing the fact that all students already have a mobile phone, and they use Duo. I don't know if you've heard of Duo, and they do the push notifications, and they use your phone as something you have to authenticate with. If you wanted to use U2F, then I don't know if there's contractors that would like set it up for you. You probably have to do a little bit more work to set it up to work with your services. But just taking Yubico software libraries, and then you can either require your students to acquire a token on their own, which adds a little bit of risk, or you can provide them with one, which adds more costs. And then you always have to deal with them like losing a token or getting it stolen. I mean, they could also lose their phone or get their phone stolen too, but that's maybe not as common, or I don't know.
It's more driven for staff per se, maybe your IT department perhaps, or someone that would.
Yeah. So I know a number of companies work on setting this up for internal use. So anyway, when you go to a workplace and you have a badge and you have to badge in, this would have the same model.
I'm Seymour Hampton. I'm a member of the board, and I thought another board member was going to be introducing Conor, so I want to apologize. But when we looked at providing you with his U2F token, we thought this is really sort of amazing that something this small could be created not by a registry, but that it could be so cheap and out there. And as we look for security issues and being in the school district, trying to figure out how do we protect people generally from themselves, not from someone else. What are some of the possibilities? And so one of the reasons we included this in the giveaway, just to help all of us start to think about other solutions. And many of you probably have a similar one to us: is how do K-1-2 kids log in to their computer? The good old a kindergartner who's looking at a keyboard may know the letter. I mean, he may have taught his letters, but he can't recognize them on the keyboard in upper or lowercase. I mean, all of these issues. So we have it from that end to the upper end of how are you securing it within your own technology team. So there are different layers of security that we need, and we just looked at this, and when we heard about it, we went, this used to be tens of thousands of dollars to implement things like this, and through a lot of creativity and obviously a lot of smarts, Conor was able to do that. So just want to thank you for your work and for allowing us to have something that we could share and to think about, to have everyone else think about how would I actually use this. So just want to let you know how impressed we were with the work that you were doing. I want to thank you for coming out here and presenting. And I just want to let you know, if you don't know anything about the Northwest, it's always like this.
That's great.
Get them on a plane.
That's great.
Hang around till 5.
Are there any other questions?
Yeah, Conor, can you design a fob that would prevent users from giving third-party access to Gmail?
So work on it.
Can't do that either.
Phishing's hard.
I have a random question. Matthew Green is at Johns Hopkins, but I don't know if he'll cross paths.
So yeah, he's a professor at the university. I'm working at the Applied Physics Lab, which is a little bit the government contractor thing.
I just knew he was doing a lot of crypto stuff. He teaches cryptography, so I didn't know if he was crossing paths.
He's definitely a big name in the field.
Yeah.
His specific type of research in crypto doesn't align with mine, but I do go over his papers, read his blog posts. But, people quote him a lot.
So can the U2F keys be used for signing into laptops instead of using your regular passwords and stuff like that?
Yep.
Because in that example of K2, I could see, having each kid's thing and they come in and click and they sign in.
Yeah, people have set their computers up to be able to log in with a two-factor auth token. I don't know too much about the official routes to be able to do that. Normally these are just homebrew ways that people figure it out, but from a security standpoint and implementation standpoint, it should work. I know remote logins and SSH too. There's like plugins you can add to SSH to be able to use U2F as well, which is nice.
I'll just add on the comment about facial recognition. Windows 10 has facial recognition built in, and so we asked Microsoft, where are they storing the biometric information? And they said it's only stored on the individual laptop. which if each of our students had their own, maybe we could actually use that after we had dealt with the parent issues of what are you collecting from my student and educated the parent on what we were doing. But in the environment where you have a card and the kid, oh yeah, I'm supposed to take out number 2, but I took out number 3, that one goes by the wayside. But you know, just different issues that we're working on. So
yeah, I know there's probably some legislation issue with collecting personal information on kids below the age of 14 or 13. They can't.
We deal with it.
Yeah.
One of our things we have to deal with all the time.
Mm-hmm.
Any other questions? Final questions?
So when you're famous someday, these will be worth money, right?
Will probably depreciate, but we'll see.
Keep it in the package.
Yeah.
Okay. Great. Oh, yeah.
We want him to sign all the backs of our tokens.
Just like that math class I'm still looking for.
Great. Oh, yeah.
Any other questions?
Yeah, thank you all. Thank you.
So when you started at Virginia Tech, was this something you wanted to go into, or was it you started at Virginia Tech and something this caught your eye?
Yeah, when I started college, I didn't really know anything, but I decided on like computer engineering, and I always wanted to like make something like physical, and so I was at DEF CON, and someone like gave me a YubiKey token. I'm like, oh, how does this work? And eventually went down the route of like I wanted to make my own. Yeah. So
could there be an application with the enterprise environment and using or storing the tokens in our Active Directory or some kind of authentication for domain logins?
If you want to authenticate to like a specific like domain, I mean, it doesn't matter too much what the application is, but if it has like a specific identity or something, you should be able to use U2F for that.
Well, I'm talking about internally, not just for, for our teacher-student logins, particularly our staff.
Yeah, totally.
Where would one find resources for that?
So, adding U2F to like new things, you probably need to have a little bit more experience how the authentication scheme works and writing like plugins for that.
Mm-hmm.
I would look at just research like how people have added U2F to like logging into like Windows machines or SSH, how people made plugins for that.
Okay.
Because you're gonna need access to USB on some machine, and then if you have Active Directory, so there's like a server somewhere that's gonna have the public keys, right? So it's gonna need to be able to communicate with that.
Okay.
And so the amount of
Were there extra fobs around? I wanted to take some back to my network team because I mean we struggle with MFA and this kind of stuff constantly, trying to figure out how we're going to deal with it.
So I have one extra one.
No, I don't. I will buy them if like I was just wondering if there was an inventory of them or something like that.
You can ask JB maybe.
Okay.
But yeah, I just made one for
Each
made
band,
400.
okay.
I don't know if you made 400
Yeah.
packs or whatever.
No,
But no, actually, I brought an extra for this reason if you want it.
No.
Okay.
I can go and I'll take care of it. So
Okay.
I appreciate it. Thanks.
Great. Well, thank you.
All right, well, great presentation. Thank you.
Great. Thank you.
I just wanted to say thank you.
Thank you.
Thanks for walking us through as somebody who's completely new to encryption and all this stuff.
No
Like
problem.
seriously, nothing. It was really nice to have that walkthrough and
Thank you.
to like understand it. So I think you did a great job. And keep going. Education is a very safe space to be in because we're glad for any information. Like as they said, we're very new. So thanks and congrats for making something and sharing it. And keep doing what you're doing.
Well,
So,
yeah. Well, thanks a lot. Nice to meet you.
You could even, they call it, you could say like, okay, for someone, there's one that we were looking into that we were hoping to on-conduct if teacher walks over and user type of student comes in, either go from a short pin to one minute. But if they get there, they try to launch a browser, nothing that we could get ready for them to do. Sorry about that. So I'm like, here's a way to invest.
I'm sure they'll become famous on the list. Yeah. No, we're certain.
But for students, yeah, because inevitably, when you look at after the fact, how do we prove it? How do we exonerate that? And we do it by preventing it from happening from the beginning. Because if we implemented something so realistic, and the teacher says, well, it's made really, yeah, right. Get real, you know.
Either that or you've got kids like carrying around rolls of packing tape, just waiting for the teacher to set their glass down for a second. Right.
Hey, so good luck with your reverse engineering and stuff. Like, what are you specifically reverse engineering? Do you know yet, or?
No, yeah, it's just things for three-letter agencies that I can't know too much about. So yeah,
you can't even know too much about it yet. So.
Yeah, I'll get a device. Like, oh, cool. I'm like, why? Can't tell me. That's right. Maybe.
But here,
I'll learn more.
break it. You don't need to know why.
That'll be it.
That's cool. That's cool. All right. Yeah,
looking forward to it.
Very good presentation. Thank you for coming out here. I mean, it's a long way from Virginia Tech. My father-in-law went to Virginia Tech.
Oh, cool.
Years and years ago. He's a metallurgical engineer now, but yeah, he has fond memories of it. So yeah, I don't know what it's like nowadays, but even today,
very growing place. Yeah, it changes a lot. Yeah.
It's much bigger than it was when he was back there. You know, he was there right before Vietnam. You know, so it was a long time ago since he's been
completely different.
probably, but you know. He still tries to keep up on it, and you know gets like the alumni stuff, and so with that's cool. Nice. What's the weather like back east?
It's a little bit warmer, I think. Let's see. Right now it's 65. Okay, that's about the same. Maybe a little bit more drier, I'd say.
Well, see, just a couple days ago it was raining here, so you hit some good weather. Have you been here the whole time?
Looks pretty nice. I just got in last night.
Last night. Okay.
So I'll probably do a little bit of walking around, seeing all the.
Oh yeah, please.
See, there's a number of events after the conference that seem fun.
Yeah. There's those after conference events, and you know if you're able to get out to some of the hiking trails nearby, you know it's good stuff. I know you got your own wilderness on the East Coast. It's a little bit different.
Appalachian Trail side, the mountainous side.
Yeah. Cool. Yeah, great having you.
Great.
Appreciate it.
Yeah, glad you liked it. Yeah, thank you.
Glad you're here now. There's going to be some other good stuff.
Might make that.
So they emailed all their counterparts. Anyone else open this?